I think the first meta question is why cellular? Why cellular versus Wi-Fi? That is now both hard and easy. And the example I always give is I met this washing machine manufacturer from Turkey. He had a Wi-Fi module in his washing machine. I have a washing machine with Wi-Fi. Have I put them on my Wi-Fi? No. Why have I not put it on the Wi-Fi? Because when I load the washing machine, I still have to go downstairs and load the washing machine and then press the button. So instead of pressing the button, I can do that now maybe from far away, but it doesn't really help me.
I said the value prop isn't entirely there for you as an end user.
Connectivity is really both a challenge and a risk and an opportunity. I always say that connectivity is in many ways such a transformative change for devices that unfortunately we can't avoid. We can create such better products, such better experiences, both in terms of what the product does for the customer, but also with how the business that makes the product can continue enhancing it, securing it, fixing it, maintaining it, thanks to connectivity without having to, get the devices back in the lab or dispatching technicians. And so it's becoming table stakes.
You get really now interesting new use cases that we can't think of. I was talking to a hair straightener company. I don't have a lot of hair, and maybe you guys don't straighten your hair either, but Martin does. And these are expensive devices. And they were going, well, actually what we want to do is we want to rent these devices, like a lease purchase of the device. But then because the device is like $400, so high-end, expensive stuff. But if you don't pay, then they want to be able to switch it off. So they were effectively, they would lose the device, but at least they can stop the user and maybe that will encourage them to repay. So they were looking at different business models and different ways of actually using their products.
Welcome to Coredump Sessions, the podcast for IoT leaders, firmware engineers, and embedded systems enthusiasts. Each episode, we bring you insights from the leaders and innovators shaping the future of connected devices. We'll talk about what's breaking, what's working, and what it really takes to build reliable products at scale. Let's jump in.
All right. Hi, everyone, and welcome to today's Coredump live session. We're talking about plug-and-play cellular connectivity, and as always, we've got some amazing guests and panelists that I will be talking about shortly. For those of you tuning in live, thank you for being here. One of the benefits of joining live is that you get to ask us some questions and shape the conversation. We will look at these questions as they come in, so thank you in advance for your participation, and don't hesitate to ask us anything you'd like. All right, so let's talk about who we've got today. My name is François Baldassari. I'm the founder and CEO of Memfault. Memfault builds infrastructure to help connected device makers build better products and get them to market faster. Joining me today, of course, as always, Chris Coleman. Chris is CTO here at Memfault. He's an embedded software engineer who's worked on, about 10 or so connected devices in his career. Chris, thank you for joining. Looking forward to the chat.
Great to be here, as always.
And most importantly, we're very lucky today to have Vincent Coredump, CEO of Kigen. Hopefully, Vincent, I got your name right this time. Vincent is on a mission to make eSIM and iSIM the foundation of all connected devices. This led him to found the Kigen Group within ARM in 2016. Kigen, as of October 2020, is now an independent company driving the vision to secure trillions of connected devices. Before founding Kigen, Vincent worked for ARM for 22 years, during which he helped build the UK's leading technology company. And before that, he worked at TNO in compiler and security technology. Vincent, we're so lucky to have you here today. Thank you for joining and welcome.
Well, thank you for that great introduction. I'm blushing, but it's great to talk to you guys. And already we had a little pre-chat, and we're, I think, already very much aligned on the technical geeky stuff we can talk about in the next hour.
Exactly. So today we're talking about cellular connectivity, something you know a lot more about than we do. But maybe before we start, let's talk a little bit about Kigen. So we heard that it was founded within ARM, that it was spun out, that it's about iSIM and eSIM technology. But tell us a little bit more. What was the vision? How has it come along? What's the story? How do we get here, and where do you think Kigen is headed?
Sure. I think now it's nice to go back to the vision of Kigen. In 2016, probably a little bit before that, at ARM, we were looking very much at kind of how can we get humanity to trust devices. Now, that's a very high level thing. How can we build so much security into devices that we don't get stories about hidden nanny cams that get hacked and all kinds of other things, especially with the boom of IoT. So what should we do? And there are many different initiatives. But one of the initiatives was that actually we believe that a secure element, and we can talk a little bit later what it is, but a secure element is a really important part of securing the device, and a really hardened way of storing some of your secrets in that device. And we saw this movement in the cellular world where they have a secure element called a SIM, but they're all moving that into something which is now much more suitable for IoT and much more suitable for devices by soldering it down and making it an eSIM. So that combination of actually, we were interested in those secure elements. We were interested in putting them into devices, as well as the cellular market starting to use that and soldering that in to secure that connectivity. Now, once you got it secured, there's lots of things you can do with that. But obviously, initially, it's around securing that connectivity. We can talk about that now in a bit more detail. But that really is now what came about from one end. And the other end, we also believe that now devices that are connected are one, more secure, but also can deliver a lot more services to customers. So we believe that a device with connectivity is really what is going to be a transformation in our lifetime. And we believe that driving that was now security was essential, but also making it easy was very essential. So those are the things that drove Kigen.
Connectivity is really both a challenge and a risk and an opportunity. I always say that connectivity is in many ways such a transformative change for devices that unfortunately we can't avoid it. We can create such better products, such better experiences, both in terms of what the product does for the customer, but also with how the business that makes the product can continue enhancing it, securing it, fixing it, maintaining it, thanks to connectivity without having to, get the devices back in the lab or dispatching technicians. And so it's becoming table stakes. But as you said, connectivity comes with risk and complexity. It comes with hundreds of thousands of lines of code to implement protocols. It comes with new hardware components, and it comes with exposure to the broader internet, which is, in many ways a hostile environment for insecure or for software generally. And so the lesson has been hard to learn. I think Chris and I have talked in the past about the fact that at Pebble, when we built a connected device, there was no security whatsoever. The firmware wasn't signed. Most of the communication was not encrypted end to end. There was some encryption at the Bluetooth link level, right, that we leverage, but that was about it. And nowadays that wouldn't fly. I think you'd really been putting your users at risk, and yet many companies haven't gotten there really. So how do we make this easy, and what technology does Kigen build specifically to make that possible?
A wide scala of topics there, but to answer that last kind of question, to me, it's all about now first of all, I think the first meta question is why cellular, right? Why cellular versus Wi-Fi? That is now both hard and easy, right? And the reason, the example I always give is I met this washing machine manufacturer from Turkey. I hope he doesn't mind me using him indirectly, but he had a Wi-Fi module in his washing machine. And I'm not sure how much in the US you have Wi-Fi in your washing machine. I have a washing machine with Wi-Fi. I am a technologist. Right. Have I put him on my Wi-Fi? No. Why have I not put it on the Wi-Fi? Because when I load the washing machine, I still have to go downstairs and load the washing machine and then press the button. So instead of pressing the button, I can do that now maybe from far away, but it doesn't really help me.
I said the value prop isn't entirely there for you as an end user.
Yeah. But for the washing machine manufacturer, he was very frustrated because he was putting a $5 Wi-Fi module in the washing machine, and it didn't connect, so he didn't get what he really was after, was the usage information. How often is my washing machine used? Are they using wool wash? Are they doing all these other things? So he was looking at a cellular modem at the time, which were probably, this is a while ago, so they were $30 a pop. So he goes, well, that is not really achievable. But he did go, well, if there's a cellular modem in there, if it's a narrowband IoT or something with a trickle of data, it will just work. And that's really beneficial for him. And he was thinking of quite exciting use cases for him, not necessarily for us, but he wanted to know the usage information, but also he wanted to use his display on the side of the washing machine and do advertisement. You're all kind of nicely dressed, so wool wash, so can I offer wool wash for half price? So you can clearly see that he wanted a different use case. He might wanted to develop his product, but cellular was one hand the answer, but also wasn't. At the time, it was now $30. That has come down in the last 5 to 10 years. I think now you can get the narrowband IoT modules around $7, $8 maybe. So you can see that is changing the market. But that's also now bringing lots of new complexity. And what we really want now, when we talk about what is the companies we really want to help, it's the device makers. So to us, our heroes, we want to help win the war of badly designed devices are the device makers. So what do we do is think very hard and work with device makers on solving their problems when it comes to connectivity. And one of the problems is that that when you take that SIM and you want to put that SIM now down onto your board, you have to choose connectivity. And you go from a SKU management problem of having multiple SIMs with multiple connectivity providers around the world to having that soldered down. But again, that also requires an initial connectivity. So that blows up some of your SKU management. Now, one of the things we do is that we effectively give you a blank SIM, a blank eSIM, and we allow you with a little programming tool outside the big cage where SIMs and eSIMs get produced. And we allow you to put in the connectivity you want at time of shipment or even in your supply chain, as well as doing an update in the field that allows you to change the connectivity. So again, thinking about what are the problems of device makers when they go from one device to a million devices now in one country and around the world. And how do you manage that? That's now a slightly long answer. I think I can keep going for another half hour, but that's one of the things we're doing.
No, that makes a lot of sense. And by the way, the story you told about the washing machine maker rings really true to me. I have, at home, I have a CPAP machine, right? Like a medical device made by ResMed. And ResMed, it was actually an amazing experience for me because it comes with a cellular connectivity built in. It's already provisioned. Everything's worked out of the box. All I had to do is plug the machine in the wall and it starts reporting telemetry to my physician, to myself. No Wi-Fi networks, nothing. I didn't have to do any pairing or onboarding step. And so I and I travel around the world. I went to Norway, I went to California, France, and it just works. It is an incredible experience. And I think, wow, as a device maker, how much BOM would I be willing to spend to make that possible? And I think quite a bit, actually. Because think about the support cost of all the people who can't get the Wi-Fi to work with their router. That is real money.
You might be able to do it, right? As a quite technical guy, but now what about my mother, right? Who doesn't know how to put in a Wi-Fi code? How to know if there's not on her phone? I have to do it for her. But if there's no interface, if there's no screen, it's really hard. So I agree. It's just making that really, really. And I think the company we can thank for actually coming up with that is the Kindle, right? The 3G Kindle it's been in the market probably 15 years. You can read a book anywhere on the beach, and you can download a new book. And you didn't have to think about now how much it's going to cost you. You didn't have to think about who you're connecting with, how you're roaming, what your contacts are. It just worked. I think that is really the experience. I think that as device makers you need to look for, and then you get really interesting new use cases that we can't think of. Right? I was talking to a hair straightener company. I don't have a lot of hair, and maybe you guys don't straighten your hair either, but it does. And these are expensive devices. And they were going, well, actually, what we want to do is we want to rent these devices, like a lease purchase of the device. But then, because the device is like $400, so high-end, expensive stuff. But if you don't pay, then they want to be able to switch it off. So they effectively, they would lose the device, but at least they can stop the user, and maybe that will encourage them to repay. So they were looking at different business models and different ways of actually using their products, based on the fact that they can always reach these.
Yeah, super interesting. And this is a great transition into the topic that I thought we talk about next, which is that there's right now we're in a shift in the availability of cellular for a wider range of products, the possibility of using cellular connectivity for a wider range of projects. We touched a little bit on the commercial piece, so let's explore that a little more, which is, you said we went from $15 to $7, maybe even a little lower in volume, dollars for cellular modules and connectivity. That enables a lot of new use cases. When you talk to your customers in the connected device space, how do they think about that cost? Number one, how do they have the broad view of overall costs in terms of support costs, software, all of this coming together, and not just BOM, that allows them to make intelligent decisions that go beyond just, X factory costs, number one. And then number two, how do they typically account for the cellular data costs? Do they tend to just build that into the product's selling price? Do you see more and more renting programs or more and more subscription services, right? Like if you're making a washing machine, are you really going to get your user to pay a couple bucks per month to watch their flows. What are you seeing in terms of the business of connectivity and of selling it to users that makes it feel like we're arriving to a good place?
Yeah, that's an interesting question. I think there are now a couple of examples where this works really well and a couple of examples where it does not, right? So obviously every customer is different and every device maker is at a different part of their journey. The washing machine guy worked it out 7-8 years ago that he initially put Wi-Fi in and nobody was using it. So this is a lesson you will learn, right, that the support cost is too high, or that actually the customers have no incentive to use your product in that way. Other ways of thinking about this on the connectivity side, if you think about how Amazon did it, right, by downloading the book. Every time you download a book, they transfer some data, so that's effectively the book is slightly more expensive. So if you look at a device that has a ongoing user interaction, right, there's a way for the connectivity to be rolled up in that. But then you also have now innovative, and quite a few innovative, what we call MVNOs. MVNOs are mobile virtual network operators. Sorry to use such a long acronym. It's effectively people that aggregate connectivity around the world. Like this particularly now, you have them in the consumer space, and they tend to be brands that bring you connectivity from one provider, maybe AT&T as a brand on top of that. We have something called Tesco, like a Walmart marks for mobile phones here. But when you look at the device maker, you have MVNOs that actually collate connectivity around the world. So you got this one MVNO and they will sort out your connectivity, be it in China, be you in, and they come up with different ways of charging you. There are a couple of them that came in. I think once was the first that started that, but most of them have now that effectively say you pay $10 for 10 years. Which effectively is
like
the lifetime,
fee, basically.
Yeah, it's a one-time fee, but that's obviously a limited amount of data or limited speed of data, especially on these new modem technologies for IoT devices, like things like Cat-M, narrowband IoT. They don't transmit a lot of data, so actually the data is quite limited, and you can have a fixed fee to do that, which means it becomes part of the device cost, right? And then effectively the device becomes $10 more expensive, or plus your margin, etc. Right. But you can see that comes a way of charging. So you get now choices. It's very much now what does your device do, and what more value can your device offer? Right, again, the washing machine example, he was looking at putting advertising on the washing machine. The hair straightener people, they were looking at at upselling you. We can measure how dry your hair is. I have this shampoo for you, especially for your, and all kinds of interesting things. So this at some point, there's no limit to your imagination. It's about bringing this to market and allowing people to have breakthroughs.
So it's a mix of two things. It's the BOM costs of cellular going down with these 10-year SIMs and these cheaper modules. Yeah. And it's also new business models emerging, like rental, like advertising, and others that bring new revenue streams with connectivity, which come together. Won't work for every device, right? Adding $15 to your BOM, if your device is $1,000, is easy. If your device is selling for $50, probably not doable. Let's talk a little bit about the technology. So first, talk about the SIMs. Chris, I know maybe you want to kick us off there. I know you've been very interested in SIM technology, and maybe talking a little bit about how it's changed recently, and maybe even iSIM versus eSIM. I'll turn it over to you. What did you what's on your mind?
I don't know. I feel like kind of taking a step back. If you look at embedded development today, most people are thinking about they're thinking about C, they're thinking about really constrained firmware and other pieces. And something that I've always really enjoyed about SIMs is I think it's an interesting mapping of Java into or Java card into the embedded world, emerged out of some use cases for supporting multiple apps and pieces. But maybe you know a bit more about some of the history there, Vincent, and how that came to be as kind of the SIM card technology.
Yeah, actually, it came from the SIM technology, where it probably was mobile network operators supporting more than one vendor. So the way the SIM works, effectively, you have a little operating system. You have the CPU operating system, bit of memory. And in that operating system, you have what they call profiles. And profile is effectively a collection of what the MNO wants to make available on their SIM card. That can be their keys, it can be applications, and it can be data stored to you. And then if you go all the way back to when SIMs just emerged, actually there were things like your address book was stored on your SIM card, and they have little games on your SIM card. Now these things have kind of sunk away because the computing on the mobile phone side has far outstripped what the little SIM can do. But actually, when the SIM becomes a eSIM, effectively all the MNOs, all the mobile networks are now sharing the same real estate. So you need to have a way for those profiles, which effectively can be loaded onto the eSIM, and the eSIM can hold now at least 6 of these profiles at the same time. They have to be able to work on any bit of hardware. So this is why the use case of Java card came in, both on that's now multiple vendors, but now also having one SIM card that has multiple MNOs on it. And that is kind of one of the ways, at least now, a way that was quite old now, but 20, 25 years old, a way to have little applications that effectively can run anywhere.
How much sort of code space or RAM space are we talking about on a modern day eSIM?
So that is always very fun because that brings me right back to my compiler days and the early days at ARM. We were talking about kilobytes, and the SIM is very much measured in kilobytes. So the low-end SIMs, or the low-end eSIMs, probably 128 kilobyte of flash. The slightly more expensive ones, a megabyte, maybe 2 megabytes. That's kind of what's there. I think typical is between half a megabyte and a megabyte of flash space. Quite sure on the RAM sizes now. I have to go down to the technical specs, but yeah, it's really small. So it's very back to keeping it small. My team in Kigen is also now specializes on having their OS really, really small. So again, we are probably the OS itself takes up like 100 kilobytes, depending on its configuration. Then the rest is space for those profiles and those little applications. So the smaller you can keep it, the smaller the hardware you can use. And again, it is quite cost sensitive. Now, an eSIM is between $1 and $1.50. So clearly, if you can do it for 80 cents, then that is now on a BOM on a device really important. So less code size directly into a lower price for the device maker, and thus now hopefully more adoption.
Code space is always relative, but when someone says 128K,
Yes.
that was like the size of the flash that we had when we built the first Pebble watch. And so I think of like, you can pack a fair amount of stuff.
True.
That's running. So it's I don't think people even think about how much I mean, it's a little code, but there's a fair amount of code that can run on the SIM cards, on the boards that they're designing.
I agree. It's all relative, but if you look at laptops nowadays, there are gigabytes and gigabytes, yes. So it's in a different dimension, if you will. But it does bring you back to the fundamentals of computer science, and obviously it's very much an embedded system. Now it's just a little bit more challenging than a general embedded system because it has all this security around it. That makes now programming it now even harder than a normal embedded system. It's already be quite hard to get to your information for both loading and debugging, and again, the SIM card has a very similar challenge. But then on top of that, there's like a big barrier that tries to not let you see anything. So that makes it a unique challenge.
If someone's updating profiles on the device in the field or kind of getting things, what's that? I guess what does that process look like? Is that something that the OS is sort of responsible for managing? Is there like a standard profile that folks use? How's that?
So every MNO has their own profile. The profile does have a standardized structure. So effectively, in the standard structure, you can add some data, some keys, some application. And effectively, what happens is that a device has an initial profile, which allows it to communicate, assuming you don't have Wi-Fi, because you could do some of these things over Wi-Fi, but assuming your cellular only device, it will have already some connectivity, and then it's managed by what they call a remote SIM provisioning server, RSP. And the RSP effectively communicates back and forth to the device, either via the old SMS system, or hopefully, if you have a bit more of a modern radio, via TCP/IP, and it communicates back and forth. They authenticate. They effectively say, "I have a new profile for you." It could be in the IoT space where you push the profile. You can say, I'm the manager of this fleet of eSIMs, and I've got a new profile because I want effectively you to switch from Vodafone to Verizon or from AT&T to Deutsche Telekom. I will download a new profile. Then you can install the new profile. Again, that's the OS task. And then you can give the OS the command to activate the profile. Because of the standard, you can only have one profile available. So one profile active. So you have to deactivate the original profile and reactivate the new profile. If it all messes up because your new profile did not have connectivity, you didn't pay, then you fall back to the one you just
rollback for the strategy. Got it.
Yeah, there's kind
not
of a
enough
rollback
RAM for multiple profiles to run.
Well, no, actually, that would be fine from a technical point of view. But I see a question about SoftSIM in the Q&A. There is a little bit of hesitation. This is a space that used to be owned by the mobile network operators. They used to have SIMs, and the SIM is the ownership of your customer. Now we focus a lot on the IoT market, but in consumer markets, the kind of switching between one operator and the next operator means you have to have a new SIM. And this is a way for the operators to slow you down, right, in their mind. So that was really important for them to hold on to that. So they are very worried is that you can have 6 different profiles active at the same time, and that creates a lot of competition in the consumer space. For the IoT space, it might make a lot more sense, but some of these things have been initially trialed in the consumer space and then coming back into the IoT space. So the standard deliberately says this is not allowed to happen. I think to keep a bit of control on exactly how this market develops, as the operators now are a little hesitant to embrace too much innovation. Similarly, on that SoftSIM question, from a technology point of view, we can do it. There is now some reduction, but you can argue a bit about that, about not using a secure element. Right, the SoftSIM is when you place the SIM software on the main application processor.
So it's a VM basically. You drop a VM in your firmware, and that can execute your Java card applets in effect.
Yeah, it could be a VM, it could be ARM based, it could be a trust zone environment. There's multiple places where you could run it, right? Secure, slightly more secure, very secure, but effectively on the application processor. Historically, there's some initiatives around that, but the mobile network operators are very worried that lowers the security barrier for their sensitive data, and it does. You can argue that you could do some updates over the air, but so far that's no. Generally, when it comes to security, right, the security vision is that you keep things really, really small, because if you keep your things really, really small, you have more of a chance of reasoning about that. So you put your very important security keys on a secure element and you keep that very small. You don't want, 120 kilobyte might be a lot to Chris, but in generally, if you compare to Linux, it's quite small. If you compare it to the modern code bases, it's quite small. So having a really small environment makes it easier to certify, and thus the mobile network industry is not happy to let go of that. From our point of view, we're a technology provider. If you want SoftSIM, we could easily make it.
But what adoption are you seeing today? Like, are you seeing projects really adopt, iSIM and SoftSIMs?
So iSIM is different than SoftSIM. iSIM is effectively where you integrate. So this goes back to systems on chip. I'm not sure now. When you are designing a processor, it used to be a CPU, used to be separate from the memory, used to be separate from the bus, all separate. But actually, modern design with Moore's law, you have so many gates. You can actually stuff it all into one chip. Right, that's called integration. You can have the application processor and the modem all in one chip. And iSIM takes that same secure element and puts it on the same chip. It doesn't change the secure element. It has the same physical barriers. It has the same analog processes defending it, as well as the same software. So it is very separate on the chip, but it effectively has its own area. SoftSIM doesn't have its own area. It's on the application processor. Now, from a traction point of view, iSIM is part of the standard, so it's fully approved, and we are seeing that coming quite a lot. It is now just the first few designs are coming to market. We were working very closely with Sony, Altair, and Murata. They are coming to market with multiple products in this. There are some vendors that are playing around with SoftSIM, but I don't see a lot of traction because it's not approved, it's not standardized. So one operator might be okay with it, but then you are exporting it into a different market and they go, no, we're not willing to play in that area. So that would be quite a fundamental shift in the industry. I think that it is slow to materialize.
And of course, when you build an IoT device, you oftentimes need multiple operators to support your product. So, some companies are in very limited markets and they might be able to convince one operators to accept their SoftSIM with some certification. But if as soon as you try to sell in a few jurisdictions, the combinatorial work that you have to do becomes overwhelming.
I was going to say, I feel like what I see a lot when someone's building or bringing cellular products to market is the way they think about it is like, let's target one region to start, like the US. And if that's good, we'll go global, or like, let's start in, one country. And if that's good, we'll go global. I'm kind of curious. Yeah. What do you Do you have recommendations, or what do you sort of see people there as they think about? I think that's one of the challenges of cellular today is to some degree the diversification across the globe. But if you're trying to build a truly global product.
Yeah. So I think the key thing is that you go with things that have been tested around the world, right? So if you're Apple, you probably design your own radio, your own cards, your own motherboards, everything yourself. But if you're not Apple, which most of us aren't, I think the first thing you do is you go to a module maker. Module maker is someone like Quicktell, someone like Sierra, Semtech nowadays, someone like Nordic. They make little mobile phones without a screen, right? Little radios for your IoT, and those radios have been tested with the different operators around the world. So that at least that's now and most operators will accept something that's been pre-tested on the network if you use that. Some operators are a little bit more fussy, but most of them are good with that. Similarly, now we test our eSIM. I think that's a question in the Q&A as well. We test our eSIM with 130 networks on a regular basis, and every time we add more networks. IoT has a little bit less networks than the consumer space, but we keep testing that, so that if you are going to say in the US market first, it works in the US. There might be a temptation to go with a SIM slot, which is fine. That means you have that physical eSIM to manage. But once you go to an eSIM, you can then choose your operator, and that is very important choice, that you think about the operator you have today. And then what happens if you go to a different market? Do you need to have a new operator, which is possible, or do you actually have an operator which can address multiple markets? Now that depends also a little bit on volume, because some of the MNOs are very good in high volume. So if you want to go to a certain region, having the biggest MNO there can offer you a price that nobody else can. While the MVNOs are much more about giving you that slightly more average price on a much wider footprint. So there's a couple of things you have to think about. Am I going to go very high volume? Then definitely I want to have a relationship with a large MNO. If I'm going much more piecemeal, and probably an MVNO might be a better company because they're more used to dealing with smaller customers.
Talking about the network, so I think we talked about technological changes that have made it possible to adopt cellular at much wider scale. One of the things that I've seen emerge over the last decade is cellular technologies that are better adapted to IoT. But with the flip side of that being that the huge amounts of the pace of innovation in cellular technologies and the range of networks that are available nowadays is a little bit hard to keep up with and to think about as you make decisions for your product. So nowadays I see, some products are still being built on 2G or 3G, although that's being phased out in some countries. We have narrowband IoT, which is more popular in some regions versus others. We've got LTE-M, we have LTE Cat 1, we have now LTE Cat 1 bis, right? I'm sure you've been on top of that. We have 5G RedCap conversations well underway. So, without going into what each of those technologies is, because that will take 2 hours.
Plus, I'm not the expert here either. So.
Where is the adoption actually taking place in your customer base? Where do you see the most momentum? And number two is, if I'm a device maker today and I'm designing a product that needs to be in the market for the next, say, decade, right? Where do I anchor? What do I hitch a ride on? Which standard should I hitch a ride on? Or what technology choice should I make? Should I start betting on? Should I get ready for 1 bis? Should I start betting on 5G RedCap? Should I just stay very conservative and look at LTE-M, or is that going to be around in 10 years? Right, today I'm building a Wi-Fi product. It's very simple. I can get a 2.4 gigahertz or 5 gigahertz Wi-Fi module. I can slap it in my device. It will work with networks in 10 years. It seems less clear for a cellular device what the default choice should be. And obviously different bandwidth. Help us think through the design space here.
Yeah, no, first of all, I don't think Wi-Fi is that glorious either, right? I have a couple of Wi-Fi devices.
No, I oversimplify.
That don't work on my network, and I have to lower the security of my network to allow them on it, and I'm not doing that. Anyway,
the big challenge we see with Wi-Fi is a lot of the low power devices don't support the 5 gigahertz band.
Yeah, exactly. So but it's difficult to give you a one answer. Now, the one answer I can give you is don't use 2G. Because 2G is going away.
That sounds right.
It actually has an end of life date, right?
I think that's sorry.
2G actually has an end of life.
Yes. In
date,
many
I think,
areas, it's already
published.
gone, and some areas it's going. I think 3G is not that far behind that. So I would go to the newer standards. And then it depends a little bit on what you're trying to achieve. Personally, I really like narrowband IoT. We worked with a partner called Skylo, and they actually also have fully implemented the cellular network protocol, but using satellites,
NTN.
which gives you, yes, the NTN. So they use the NTN for narrowband IoT, which is a really interesting space because there where there is no network from operators, you can actually use the satellite network on the same frequency. I love that use case.
But it's crazy that works too, if you think about
Yes.
it. Like a little
Yes, and
cellular modem.
Yes, and they don't have to
Talking to
use
satellite.
the same as Mr. Musk, Starlink, because they don't have to put satellites in space. They're just reusing the TV satellites we're no longer using because we're all on fiber and we're all streaming, and those are doing nothing. There's a great use case. It allows you to, the example I give, it allows you to go from Shanghai Harbor, you sail out onto the sea, and then you go into the network, the satellite network, and you go back on the cellular network when it's available.
Same
Nice.
the IoT radio, which is very cool.
Yes.
The fact that it
Yes.
just implements the same protocol, but from a radio in space, I think that's
Yes.
very, very interesting.
And on the SIM as well. The SIM is involved. Me too. That's why I like talking about it, because it's just a normal roaming, right? It's effectively, it will look at, okay, I'm abroad. I do not have my home network. What network is available? Oh, there's an NTN network available. Clearly, I'm sure it's not as cheap as my home network. It's normally Jerome. I don't know the pricing, but I assume, right? So okay, I'll select that only when I need to, and then I fall back to other networks. So that's quite nice. I think the Cat M, right? Cat M Bs. If I was designing today, I think if they have a slightly higher data rate, so a lot of the modems have both narrowband IoT and a Cat 0 or Cat M. So narrowband IoT for the bits. Say I'm a temperature sensor. I send the temperature every day. You do that on narrowband IoT, and then if you have a software download or a firmware update, you use a higher bandwidth radio. Quite a lot of the module makers will have like multiple radios onto your chip, and okay. And I think that from that point of view, you probably want, now if you really want to stay in the market for 10 years, you probably want to have more than one radio on that same chip. So you select one that has multiple, because that's how mobile has solved it at some point, if you remember. Maybe you're not that old, but when we had a phone that didn't work in the US. Why? Because it had CDMA in the US.
Absolutely.
And then I got a phone that worked in the US as well. Not because the US had changed, but because my phone now had a radio that could also do CDMA. My phone could do 4 radios. Some of that is still now, it's definitely available. So you have multiple radios, but I think now Cat M and Cat M Bs is higher bandwidth. I'm not completely familiar with RedCap. No, sorry, I haven't read up on that.
The challenge we see too, like when you like with NB-IoT, for example, is like it winds up being somewhat regional with respect to like which networks or providers support it. So like NB-IoT coverage in the US, not the greatest. NB-IoT coverage in many parts of Europe or Asia, quite good. Is kind of the reports I hear, at least.
Again, that's why you have now maybe a module with more than one radio. Again, Cellular can take care of that for you. But yeah, you do need to think about what is my throughput going to be, what is my radio needs are going to be. Do I switch on a higher throughput radio, which is going to be more energy inefficient or using more energy versus a very small narrowband IoT. And if I'm in the US, maybe I don't have narrowband IoT. Maybe I have to do the Cat M. But when I export it, so yeah, lots of choices.
And pardon my ignorance here, but if let's say that I have a Cat M or Cat 1 radio, I buy module that does Cat 1 and does narrowband IoT, and I start, doing this intelligent routing of data across networks based on the type of data that I'm sending, do I need specific eSIM? Right? Is there limitation there? And also in terms of the MVNO or the MNO that I'm using, are there basically networks where I can roam on NB-IoT networks, I can roam on Cat 1 networks. It's all transparent from a subscription and billing perspective.
So you don't need a different eSIM. The eSIM is the same. So the eSIM is radio independent. We have a nice marketing slide that says we work with all radios, but that's because it's independent of the radio technology. It can even do NTN. So that is the same. You make an interesting point on the MNO or the MVNO, especially the MVNOs. Not all of them will have deals accessible to the different MNOs. So the MNO might have now 4 different networks: narrowband IoT network, a Cat M network, and a RedCap network. But the MVNO might have only bought space on the the Cat-M network or the narrowband IoT network. But you can normally go to them, and they can ask them what the other networks you're supporting, and these things change as well. So that's to make it confusing, that today now you use this operator and they don't have narrowband IoT in the US because there isn't much, but now the US is heavily investing in that and more is available, and then they want to sell it. So the MVNOs will pick it up. So there's some of these things are not as transparent as they could be. It's not just this one thing will work around the world. And then again,
got it.
Makes it a little harder than Wi-Fi. Sorry?
I was going to say sometimes the MNOs will treat the direct traffic a little bit differently than MVNO stuff on the network as well, which is interesting.
Again, if you want the highest throughput, the largest volume, then probably going to the native network gives you the best deal. But then if you are only doing 10,000 devices per year, they might not pick up the phone. Right? They might not be interested in.
If there's profile updates, kind of stuff you're talking about on the SIM, or kind of we're pushing down an update, who hosts that service itself, the kind of SIM provisioning service to send down those updates?
So that depends a little. That gets you into an area we're talking about. That depends a little bit on the standard. So initially, the GSMA came out with the M2M standard. The M2M standard was the first standard that was trying to go after IoT devices, and it's quite well known that actually Apple was asking for a consumer standard, and then the MNOs responded with a device standard. That was it's called the SPG. So I apologize for using this jargon. That is it was introduced about 20 years ago. Then 10 years later, they followed up with the consumer standard. The consumer standard is what we all know. Apple pushes it really hard. Samsung pushes it really hard, and it effectively allows you to do a QR code at the airport. So you do a QR code, it downloads, it goes to the MNO where you bought the QR code. It has an RSP, a remote SIM provisioning server, and it will allow you to download your profile. Your profile has all your information, and now you can make your calls. The M2M standard is a little different because there's no interface, so it effectively has a kind of a fleet management concept. That fleet management sits at the MNO or the MVNO, so they do it for you. So you'll tell your MVNO, please switch these 10 devices to a different profile. Now that's a little clunky, and actually people like how the way it works in consumer. So there's the GSMA has worked together with Kigen and others on this new standard, the SGP32 standard, and that effectively combines the consumer and the M2M into what we call the eSIM for IoT. Now that is now going live as we speak. People are doing POC, so I think in the next 3 months that will be available for most vendors. So it's definitely something I recommend, and that allows you to have that fleet management capability yourself. So now you have the profile
device operator as the user of the device, as opposed to the OEM or the MNO.
As opposed to the MNO. So the OEM or the device operator or multiple places in the ecosystem can then decide, these are my 100,000 devices, I want to manage them, or I want my customer to be able to manage them. So that's a much better standard.
Cool.
You can also use the QR code. So if you have a QR code reader, you can use a QR code. So this is a bit about the consumer, but you can also download the QR code onto your server and then push the profiles. You have a lot more control over what is happening. So that allows you to do fleet management. I know that my fleet is currently on this tariff. I have negotiated a better tariff with a different operator. I can now download those onto all my devices, and I'm on a better tariff. I saved some money, or I didn't like my MNO, or was in a different country. There's lots of different things. Zoom is bringing me things. A lot of different things that you can then now do yourself.
About bootstrapping, we talked about, okay, we have a device that's online. We don't want to update the profile. You can connect to the server. That's all fine. But how do we bootstrap these devices onto the network? When are they initially provisioned so that out of the box they can connect somewhere and then potentially they can go and fetch a new profile, right? But there has to be connectivity. What do people do there?
So multiple use cases, right? Depends on your device. The mobile phone tends to use Wi-Fi initially. People put their mobile phone on Wi-Fi and it downloads via Wi-Fi. That is not normally available for devices, IoT devices. So in IoT devices, you need to provide that now before it ships, and that comes back to the in-factory provisioning I talked about. You effectively have that eSIM, so you could buy some eSIMs which have already got now, say, Verizon connectivity included, and then by having that, it gets connectivity, and then I'm in Germany, so I have to download a Deutsche Telekom version. We actually, for our device makers, created that in-factory provisioning tool, which allows you to have a completely securely manufactured eSIM with all the keys in it, but blank. And it allows you then to just before you ship to put the right profile on. Particularly use cases we developed this for us was smart meters, because smart meters have to arrive in the country. They're not allowed to use American connectivity when they go to Germany or vice versa. They have to arrive at the right connectivity. Right. But also these profiles can be quite large. So some profile can be 10 kilobytes in some cases, maybe 50 kilobytes. And some things like a water meter, as an example, it runs on a battery, doesn't have electricity. So if you download the profile, that might drain half the battery. So you don't want to necessarily do that. So you want to ideally go out of your factory or into your supply chain and put the right connectivity at the right point. So that's kind of how it tends to work. And when you have that initial connectivity, then you can switch if you wanted to, but again, sometimes you don't want to, or you don't need to.
So this, this adds some level of complexity in the factory, in the same way that products that I've worked on, we'd have a station where we provision keys or certificates on devices for, end-to-end encryption. You'd also have a station where you provision the profile using Kigen's technology, for example. Do I have that right? Yeah. So you build this into your factory processes.
It is. You effectively, because you have every device has its own connectivity. Every device has its own identity. So you effectively have to create a subscription for every device that can be rolled up in an account, but effectively every device needs to get different information. So we would provide you a batch file that says you have 10,000 effectively eSIM profiles, and you can then download them on all your devices. And then once they're done, you can get another 10,000 as an example. So that's part of the
Do you need an HSM for that? Or do you need an HSM for that? Or
no?
Is there traffic in SIM profiles? Do you get sometimes your manufacturer who steals a few of your SIM profiles, or is that not a concern?
Well, it depends a little bit on how much you trust your supply chain, but you know that you have 10,000, you made 10,000 profiles available, and hopefully you get 10,000 products back.
Yeah.
So from that point of view, and a SIM profile can only be used once. You cannot use it. These are all signed, right? They're all signed profiles. They can only be used for this specific product. And you have to give effectively, we want for these IDs, we want profiles, and then you can get the profiles back. So there's a handshake happening between the generation of the profiles and you downloading it based on the key that happened in that secure room when the eSIM got produced. And that has HSMs and that has cages and docs and all kinds of other protection when that happens. So that's generally, if you have 10,000 devices, you cannot just put it on another device. So if I steal your profile, it doesn't load on another eSIM. It is only made for this one eSIM.
And it can probably be voided.
In your system, you can retract it. But again, this is pretty safe. Now, obviously, if out of your 10,000 devices, 100,000 or 100 disappear, then that is a problem you have anyway. And that is now based on your connectivity, but it's also your device. So hopefully you can have some security in your supply chain.
And before we move to questions, is there any, if you had a device maker, an OEM who came to you and said, Vincent, I'm going to make my first cellular connected device. I want this magical experience of the device connects out of the box. I'm done with Wi-Fi. What would you tell them? What's a few practical things they should consider? Let's say pitfalls they should avoid. Like, what are basically 2 or 3 pieces of advice you'd give the new entrants to cellular technology who's trying to build a product with them? Anything come to mind?
I think first thing is go to a module maker. Right? The module makers have a depth in both modules in all kinds of different dimensions. So you're talking about all these different standards, all of these different and they are very knowledgeable and will give you really good insight. I think probably I go to think about the connectivity side. Now, are you going to go in one country or are you going to set yourself up for multi-countries? I think initially it's not super important. The first 10 or 100 devices you do, you can prototype. But once you go to production, you might want to start thinking about that. And again, there's that big trade-off between is it something that just works around the world? Or is it something that is really optimized for this one use case and it's kind of high data? And then the other thing is the battery life. I think that's always a very important thing from when you look at devices. Are you a battery device, right? Or are you a power cable device? I think that also makes a big difference on the choices you make. I think back at the mobile phones or mobile phones in general, right? They last a day, maybe 2 days. And clearly, if your device has to be charged every 2 days, then that might be not as optimal. So think really much about how much communication do I want my device to do and do I need my device to do? If you look at a temperature sensor, once a day, the temperature should be enough, right? You shouldn't be doing firmware updates every day because that is draining your battery. So you really need to think about this as a system approach on how much radios are expensive because you have to put out that energy to broadcast. So if you don't have a power source, then you need to think about that broadcasting as being quite painful for running on battery.
Yeah, and there are lots of technologies, by the way, and Chris, you probably can say more about this. There are lots of technologies out there that let you get more, optimized power usage on a given module. We're very familiar, obviously, with the M91 modules, and this is the thing they do best, low power connectivity. But Chris, maybe you can talk a little bit about some of these features that people oftentimes don't know about or forget, and that can be very impactful from a energy consumption perspective.
What I see a lot is when people think about Vincent's last point around data budget and how much you're sending, if it's a temperature sensor, you obviously don't have to send as much data as if you're like streaming video. But what I see a lot of companies start with is they think about the cost of the data they're sending, right? Oh, it's one temperature reading, it's 4 bytes that are being sent. And what the question they don't ask themselves is sort of like the underlying transport they're using, UDP versus TCP, TLS versus DTLS. And like setting up a HTTPS connection, cost of a TLS handshake is on the order of 7 or 8 kilobytes. So if you're sending 4 bytes of data, the data you're sending does not matter at all relative to kind of the budget that you're setting yourself in. And if you're using something like CoAP, which is a UDP-based transport, you can drastically reduce the size because the handshakes are a lot less and get down to conversationally like 5 or 6 times less data sent every time you transport data. So think about, I guess, I would highlight, think about the transport you're using and sort of like what you're wiring up on top of the stack when you're doing that data modeling piece.
Software architecture more so than the silicon ends up in very interactive products determining overall battery consumption. And so thinking about the software architecture as a battery and power management decision, I think is very important. Sorry, I interrupted you, Vincent.
No. Similarly, I would go up one level. I'd say system architecture. All right, there's also things like now, how often does your device wake up to go and see in its mailbox if there's something there? Right, it might be 4 bytes you're sending, but if you are waking up every hour, that means you're powering up your modem every hour. That means you're draining battery for nothing to be there. How connected does your device need to be? And again, it depends a little bit on the device. If it's a streaming device with lots of megabytes streaming and on a power plug, you might not worry too much about it. But if you are on the battery, thinking about the system and thinking about how often do I need to do all these things and what are the protocols and what are the outer envelope design decisions I'm taking.
That's a good one too. Like a lot of data sheets will highlight the RX and TX power, right? Like, oh, this is 3 times less TX power than any other chip out there. But ultimately, if your device is waking up, once a day to send 5 bytes of data, the amount of power that's being burned in sleep mode, or the amount of power that's being burned when peripherals or sensors are waking up is going to have a much larger impact than the amount of power spent transmitting data. So that's a system architecture level thing.
Let's in the last few minutes, let's answer some questions. I see Louis Fox has a question about interoperability between eSIM products and cellular modules. So let's say I'm buying a NRF91 or I'm buying another module from Murata or someone else. Do I have to worry about which eSIM products I can pair it with? Is this is the interoperability already completely figured out by the module vendors? What's the test matrix there?
Yeah, so it is figured out by the module makers, and generally you don't need to worry too much about it. But to make sure you really don't have to worry about it, we actually have started a little program with Kigen called Security by Design, where we work together with the module makers, Nordic being one, and a few other module makers where we work together, and we have now already tested that to make sure it's absolutely without a problem. It gets a bit when you start innovating, right? Some of these innovations now, even though they work generally, they work with connectivity, you can download it, but some of the management and some of the innovations we're doing, not everybody has those innovations. And I'm sure that some of my competitors will have other innovations. So there'll be some differences, but generally they will work. They just won't offer all the features that everybody else offers. And again, that's security by design with Kigen, what we are working with the module makers. Because again, we are very, very focused on that device makers and making sure that they get to market. So having it pre-tested by the module makers is just taking any risk out of the system.
Awesome. Well, thank you, Vincent. We're just about at time, so
perfect. Thank you.
I'm walking away even more of a believer in Cellular than I was at the beginning of this conversation. So I can see it's a big part of the future of IoT. Thank you for your knowledgeable, great answers, your patience with how little you know about some of these topics. Thank you, Chris, for joining us as well. And best of luck with Kigen. Look, I hope you'll stay in touch. And to all of you in the audience, thank you for your questions. Thank you for joining us. And we hope you have a wonderful day.
Thank you.
All right.
Thank you very much.
Bye, everyone.
Bye.
Thanks for tuning in to this Coredump session. If you enjoyed the conversation and want to dig deeper, check out more episodes available wherever you get your podcasts, on YouTube or at memfault.com/webinars. If you have any questions for our team, drop us a line at team@memfault.com. Until then, keep shipping. See you next time.